Hello everyone, welcome to Pepcoding. In this video, we will look at this interesting question, partition array into disjoint intervals. Okay, so let's take the question statement. Okay, so it is saying that given an array integer nums, partition it into two contiguous subarrays, left and right, so that every element in the left is less than or equal to every element in the right. Left and right are non-empty. Left has the smallest possible size. Okay, return the length of left after such a partitioning. So let's take the sample test cases and let's see what is actually happening. Okay, let's see the sample test cases. Okay, so it is saying that we have integer array, right? We have an integer array. Let's take this array only 5, 0, 3, 8, and 6, right? And we have to partition it in some way that if we partition it into if we partition it like this, like we have to partition it in some way that all the elements on the left hand side of this partition are less than or equal to all the elements on the right hand side. Okay, so this means that if I take 503, right, if I take 503, they are less than equal to 8 and 6, right? And since this is an array, if I partition it like this, I will get this array and this array. So it is telling me to partition it in some way that I will get two arrays. The element on the array on the left hand side will contain all the elements which are less than or equal to the elements on the right hand side. Okay, so I have to partition it in it this array in that way. Okay, let's take another example. Let's see this case, right? 1 1 1 0 6 and 12, right? So if I partition this array 1 1 1 0 6 and 12, if I partition it like this, then every element on the left hand side is less than or equal to every element on the right hand side. Okay, so what is partitioning actually? If partitioning is, let's say I have element a1, a2, a3, a4, a5, a6, a7, a8, and a9, right? I will partition it here. I will partition this array here if and only if all the elements on this side are less than or equal to all the elements on this side. Okay, so what is partitioning? I have to partition this array. I will have this array, and I cannot break I cannot pick some characters, right? I cannot pick these two values, this value, and this value, which are less than or equal to this value, this value, this value, and these two values, right? I cannot do that. I cannot specifically pick values. I have to use a contiguous subarray only. Okay, so I have to partition it in some way that if I partition it like this, all the elements on the left hand side will be less than or equal to all the elements on the right hand side. Okay, so how are we going to solve this question? Okay, before solving this question, let's see the impact of every element. Let's take, I have this array, let's say, and now let's sort this array. Okay, let's sort this array so we can see what the impact of every element is. Okay, so if we sort this, we will get 3, 6, 9, 10, 11, 12, 13, and 15. Right, we will get this after sorting. Now, if we see the right position of every character, right? If we see 10, now this 10, this 10 wants to be here, right? This 10 wants to go here, right? Because this is the right position of 10. This 10 wants to go here. Okay, now this 6 wants to stay here only. Okay, so 6 wants to stay here only. Now we have 9. 9 also wants to stay here only. 3 wants to go back, right? 9 wants to stay here. 3 wants to go to the 0th index, right? Now we have 11, right? This 11 wants to go. Let's use a different color. This 11 wants to go to this position, right? Or let's start with 12 only. 12 wants to go to here. This 11 or this 15 wants to go to the last position, right? This 11 wants to go to this position. This 13 wants to go here. Okay, so if I sort this array and I see the impact of every character, you can see that all of these positions or all of these lines represent what are the impact of every character. So this 10 wants to go here after sorting. This 3 wants to go here after sorting, right? 3 wants to go here. 10 wants to go here. 6 wants to stay at its place only. 9 also wants to stay at its place. 12 wants to go here, right? Then 15 wants to go here. Then 11 wants to go here. And then 13 wants to go here. So these are the impacts. But what does this mean? This means that if I partition it like this only, if I partition it from here, right? If I partition it from here only, if I partition this array like this, you can already see that every element on the left hand side is already less than or equal to every element on the right hand side. Okay, so I will guess the impact of every character, and if I know the impact of every character, I can say that where that element is going to lie, right? What is the range of my impact? This 10 wants to go here after sorting, right? But if this 10 was here, let's say this 10 wanted to go here, right? Here was the actual place of 10, or let's say here was the actual place of 10. If 10 wanted to go here, then we would have said that 10 had an impact. 10 The impact of 10 is here, right? So what will be my sorted array, or what will be my partitioning, right? At that moment my partitioning would have been this whole array only, because I am calculating the range of the impact of every element, right? Here you can see that the range of the impact of these elements are till this point only. So if I partition it like this, then all the elements on the left hand side are going to be less than equal to all the elements on the right hand side. Okay, all the elements on this side are less than or equal to all the elements on the right hand side. So we just need to find the impact, and on the basis of that impact we are going to do some work. Okay, so how are we going to solve this? Okay, let's discuss the solution. We will make an array called rightmin. Okay, now we will have a rightmin array, and we will maintain a left max. Okay, we will maintain a left max. Let's remove these. Okay, also we are going to have this 8 here. Now we will have a rightmin array, and this rightmin, we are going to maintain this rightmin array, and this will calculate all the minimum elements on the right hand side, right? And we will maintain a left max. This left max is not an array actually, it is just a variable, but we are using this array to represent the impact. Okay, so all the elements on the right hand side of 13 which are minimum is infinity, right? Here we'll start with infinity. Now uh, the minimum element on the right hand side here is 13. From here it is 11, right? The minimum elements on this sub array is also 11. On this sub array is also 11. Here it is 3. From here it is also 3. From here it is also 3. From here it is also 3. So this is my right min array, right? It is calculating the minimum element on the right hand side, okay, from that position. Now what is my left max? My left max can be set the minimum, the maximum element on the left hand side. So here it is 10. So here also it is 10, 10, 10, right? Till this point, the maximum element on the left hand side is 10. Here it is 12. Here it is 15, 15 here, 15 here, and 15. Right? So now we have two arrays. This is not actually an array. We are just maintaining a variable, but we will see what we are actually doing. Okay. Now we have these two arrays, and we are going to traverse through these arrays, and we will guess the impact of that of every element. Right? What we are doing is uh, we are trying to find the impact of a character of an element. So let's say I take this range, right? I take this first element, and I take this first element, and I compare it with this, right? From the I plus 1 right min, right? I take the left max, I take my left max, and the left max of the first array, or of the first from the 0th position, and I take the left max and I compare it with the minimum of my right hand side, right? So if I compare it like this, you can see what is the impact of 10 on this 3, right? Can it include it, can this 10 include this 3? What does this mean? This means that can this 10 exhaust this 3? If these were to be in a continuous subarray, can 10 exhaust 3? Yes, it can, right? 10 can exhaust 3. So we are just going to increment our operators. So we will have a I here, and I is going to increment. It is going to go here. Okay, now we see we also have a 10. Now can this 10 exhaust this 3? Right? This 10 can also exhaust this 3 from here, right? So it means that it will also include, so I'll go here, right? Now I have this 10. Now this 10 can exhaust this 3 as well, right? From here. So I'll again go here, 10. I will have this. Now what do we see? We see a element which is greater than 10. What are we actually trying to do? Okay, this will give us more insight. What we are actually trying to do, in my left max, here I have a left max, right? I'm trying to find the maximum element on the left hand side of the array, right? And here I have the minimum element on the right hand side. So if I know the maximum element on the left hand side, and if I know the minimum element on the right hand side, can I just not say that if there comes a point when when the left max is less than the right minimum, which means that at that point in that array, the left max of that array, the left max of that array is less than the right minimum, right? Uh, if you have done binary search trees, right? In binary search trees, there's a property that for every node, let's say this is 5, you will have 2 here and you will have 6 here. Every element on the left hand side will be smaller and every element on the right hand side will be greater, right? This is such a partition only. And you can say that the maximum element on the left hand side of this binary search tree, will always be smaller than the minimum element on this right subtree, right? I would have 3 here, and this will always be smaller. Let's say this is 7, right? I will have 6 here, then I will have 3 here. Now the maximum element on the left hand side, which is 3, will always be smaller than the minimum element on the right hand side, right? So we are doing the same thing here. We are calculating the maximum element on the left hand side, and we are checking it if it is smaller than the max or the minimum element on the right hand side. So it means that if there's a value, if there comes a value which is that at this point, you can say that at this point every element on the right hand side has, the minimum element on the right hand side is greater than my maximum element, right? At this point, the minimum element on the right hand side is greater than the maximum element on the left hand side. So this means that at this point, that at this point all the elements on the left hand side have a maximum of 10 and all the elements on the right hand side have the minimum of 10, right? So if at this point the maximum, the left max, is less than or equal to the right minimum, right? At this point the left max is less than equal to right minimum, right, which is 11. So I can say that this is the point where I will partition, because all the elements on the left hand side are or the greatest element on the left hand side is smaller than the minimum element on the right hand side, right? The greatest element on the left hand side is smaller than the minimum element on the right hand side. This is what we are trying to achieve. Okay, so if I know this position, then I can simply return I plus 1, right? If I'm starting from I here 0, right, I'm starting from 0, then I can simply return I plus 1 and that will be my answer. So if I write my steps, what we are doing is we're calculating a right min array, right, or maintaining a calculating, this will be calculating or maintaining a right min array, and two, we are maintaining a left max, right? We are maintaining a left max variable, or let's just call it left max. We are maintaining a left max which is going to check if the value of left max is less than equal to the value at right minimum. If there comes a point where left max, if the value at left max is less than equal to the value at right minimum, right? If there comes a point, then I can simply say that this is a part where I have to partition. This is a part where I have to put partition, and I will store the index here, right? Store index here, and I will break my loop. So this will be more clear as we code, but let's try to code this now, and we will understand it as we code. Okay. So the first thing that I'm doing is, let's take the array length out, right? So first I need to make a right min array. Okay. We need to make a right min array, which is new of int n plus 1. Okay, because we are making it a size of plus 1, right? Because we want to check from the index plus 1, right? We want to check it from the index plus 1 side. So we are here, we are at this position now. At the last position of r min, or r min n, at n we will have integer dot max value, right? Infinity is there. Now we will run a for loop from n, or from I equals to n minus 1, I is greater than equals to 0, I plus plus, and we will get our right minimum. So r min will be, right, r min of I will be r mat dot min, math dot min of r min of I plus 1, right, and r min or array. Okay, so first we need the array length. Okay, now we need to make our right min. Okay, so int right min, and this array will be of size n plus 1, right? And now at the end of this array we will have the integer dot max value, right? Infinity as is at the end of this array. Now after this right min, we need to check, right? So int I is equals to n minus 1, I is greater than equals to 0, I minus minus. Now we have to fill this right min array, right? So I will check or my right min of I will be the math dot min of right min of I plus 1 and ARR of I, right? And I'm checking it with every element on the right hand side, right? So I'm checking every element on rmin plus 1 and the current array character, and I'm filling it the minimum value of those two characters in my right min, right? So after this, after I've done this, I've got my right min which is completely filled. So I need my left max, right? And my left max will be integer dot min value. I'll initialize it with integer dot min value, and I will run a loop from 0 till n, right? Now I need what is going to be my left max. I have to maintain my left max. So left max will be mat dot max of left max and the value, right? So array of I. Now I need to check if left max of if left max is less than equals to right min of I plus 1, right? If there comes a point when left max is less than equal to I plus 1, I also need an answer, right? So that will store the index. So int answer equals to 0. If there comes a point when the left max is less than equals to the right min of I plus 1, then simply I will say that I or answer will be my current index, right? And after that I'll break my loop so that uh, since this is completely traversed, since I find the first partition, I will break this loop, right? I am maintaining a left max, right, which is the maximum element on the left hand side, and I'm comparing it with the maximum element or the minimum element on the right hand side. And if I get an element like that, then I will store this index and I will break, because I only need the first partition, right? So I'll break after this, and I just simply return answer plus 1, because at plus 1 index I will have my partitioning. Okay, so what we have done, we have taken a right min array of n plus 1 size, and at the end we have had an infinity value, right? Now we are checking for the two values like this, right? For array of I and the right min of I plus 1, we're checking these two values, which is the minimum one, and we're filling it in the right min array. And after that we have our left max, which is integer dot min value, right? And our answer, this answer will store our index. Now here in this for loop, I'm running from 0 till n, and I'm checking for my left max, which I'm maintaining here. This left max I'm maintaining here is checking if my left max is at any point, my left max is less than equal to my right min I plus 1. If there comes a point when my left max is less than equal to right min plus I plus 1, then it means that I've found a partitioning. I've found the first partitioning. So I've stored that index, and I've come out of the loop by using break, and then I'll just simply return answer I plus 1, because that answer of plus 1, because at that position plus 1 will be my correct partitioning. Okay, let's run this code. It's submitted. Let submit this. Is also accepted. So I hope you understand this question. If you don't, I will suggest rewatching the part which you don't understand. Don't forget to like, share, and subscribe. Thank you for watching.